Thank you for your kind introduction. I am Katsuki from Entity Data. I'd like to present under the title of Evaluating the Potential of Quantum Annealing for Your Business Applications. We use D-Wave, and D-Wave has invited me to speak to you today as a user. So I'd like to do that, exactly that, from the perspective of D-Wave user. Let me introduce Entity Group and Entity Data. Entity Docomo and Entity Communications often run TV commercials, and you might use Docomo's smartphones, but Entity Data you may not hear of. Entity Data does strictly B2B businesses. Our customers are governments, financial institutions, and large enterprises. So these are business areas. On left top, manufacturing and logistics. We have systems for ports and manufacturing lines. And in financial service industry, we offer credit settlement systems as well as bank-to-bank communication systems. So, in a nutshell, our customers are enterprises, financial service institutions, infrastructure operators, and government offices. So we develop platform type of systems. We build lots of systems, and we do R&D and applied studies. For quantum computing, Entity Lab may be better known. Entity Lab does long-term basic researches and publishes papers. Entity Data is closer to our customers to see how the technologies can be actually applied in the field. So I've talked about Entity Data. Why are we interested in quantum technologies? On the left, as you can see, there are various businesses of our customers working on the computational problems based on DX and AI. For example, making their logic faster. On the other hand, we have C's technologies in quantum computing, cloud, OSS, and other tools are available in this field as well. As Entity Data, in order to apply the technologies into systems, we develop applications as well as solutions, especially as you can see on the left, we are positioned in between because we support businesses using technologies. Within business, our customers may be interested in quantum computing. We run POC for them and introduce them some seminars and other contents that are available. We have track record of systems development. Therefore, the use of cloud, the use of OSS are the areas we can offer valuable advice to our customers. So, within the different phases of the technologies or maturity of the technologies, what we do would be different. Here, I have listed quantum annealing, quantum gate, cloud technologies, and security. Quantum annealing will be the area where we have long-term algorithm researches, including publishing papers. Human resource development is an important aspect of new technologies, and when we find anything valuable, we publish papers so that we can eventually contribute to the area of quantum or gated quantum computing. In case of security, we already have a dedicated team to look into the possible security solutions. Today, I will be focusing on quantum annealing. D-Wave systems applications will be introduced today in this area of quantum annealing. First of all, we will let you know what, as a user, we are doing with D-Wave, and toward the end of my presentation, I would like to share with you some application areas. Now, here is a look back at a recap of D-Wave services. The applications would be the combinatorial optimization, And the machines delivered are D-Wave Advantage for quantum annealing. But if you want services and other features, they also offer D-Wave Hybrid Solver services. So different services are offered on top of the platform. You can use D-Wave on the cloud, D-Wave Leap. And also Amazon Bracket is available as well. Overall, D-Wave has services for business applications. Over the past 4 years, we have been using D-Wave. Actually, individuals can also register to try this out. So that was about D-Wave. Now, combinatorial optimization of D-Wave can be used in different areas, and here is an example of AGC, a glass manufacturer. Now, from the mother glass plate, you have to cut out window-sized glass pieces. And of course, they want to minimize the glass loss when they cut the mother glass. Minimizing the waste can be computed by existing computation overnight. But during the day, as the plant starts to operate, they often experience glass breakage. And therefore, they no longer can apply the computed results to the glass. In order to avoid loss in efficiency, they want to have real-time response in reorganizing the glass cut. Now, different from cutting paper with a pair of scissors, in case of glass, they have to face guillotine cut constraints. Such constraints have to be considered as well. D-Wave quantum annealing can be applied to this type of a problem, and we validated the results out of D-Wave. The results have been published. So if you're interested, please refer to it. Now, D-Wave machine can also be applied to machine learning in AI. During the learning phase, the computation has to be accelerated. Especially the difficult problems can be given to D-Wave. So there are problems which quantum annealing can do a better job. So at NTT Data, we conducted various experiments. On left top, you see the equation. NTT Data does most part of the learning algorithms, but then the difficult part would be given to D-Wave for a solution. Now, if you go through this cycle, the communications delay can become a bottleneck. In that case, algorithms on the cloud can be better utilized, and D-Wave's hardware can be tuned to do the graph embedding to make it more efficient. So there are multiple ways of going around. In applications, you may face various challenges which are not delineated in published papers, but we work on them and come up with solutions. So I've talked about numerical optimization and machine learning. If you want to apply it to your systems, you may want to connect it with the cloud or existing IT systems. At NTT Data, we use clouds from different vendors. Yesterday, Utsunomiya-san of AWS made a presentation, and cloud providers are also offering quantum resources. So there are other services and existing computational platforms and AI functions which should be connected with quantum technologies, and that is what we are working on in organizing such ideas. And there may be some challenges which we call on the feedback, which requires attention of the vendors, and that's when we call on to those vendors, introducing those challenges and possible solutions. Now, Let me do a little bit of a deep dive to discuss some traps as we discover as we talk to our customers. First of all, for those people who are not familiar with quantum computing, they may not understand what the combinatorial optimization. Actually, however, this can be quite useful in business. As you search, you may understand what it is, but it doesn't. Icing and QUBO become important parts to understand, which may not be a part of the knowledge you may be able to acquire firsthand. Now, from the cloud, they can offer some free trials. So it's very recommendable that you try that out. And also, we have the quantum computing guideline at NTT Data. If you don't know combinatorial optimization, you may find it difficult to find how to use it. But then we have the PDF documents which can let you learn that basic part of it. So here's an example of how that can be used. So D-Wave Leap has a free trial. And if you install Python on your PC, you can touch it. But still, you have to understand what the combinatorial optimization, so you can refer to these guidebooks. As long as you want to touch the quantum computation or combinatorial optimization, at least this combination offers you a very basic learning of what it is all about. We also offer some sample data as well. So that is the first step of quantum annealing. Now, I'd like to introduce to you what we do with Tokyo Institute of Technology. In step 1, you understood how to use it. So the step 2 would be to find applications to businesses. Now, D-Wave has benefits or strengths and weaknesses, and you have to find where their strength can be applied. So here is an example. Now, step 1 technology part is not something that I can go deep into, so please bear with me that I have to skip that part. The source code, by the way, is published, so if you're interested, you can find it on the web. Now, here is the optimization of sport scheduling. Let's consider soccer. Soccer teams are located in Hokkaido, Tohoku, Kyushu, Kanto, and so forth, and those teams have to be matched. Which teams are to have a match on which day, where, that kind of a schedule. Now, which stadium to hold the matches can become a problem. For example, the game between Kyushu and Kanto should not be held in Hokkaido because you'll eventually lose the proceeds out of the games. You have to play the home grounds in either of the team, but you cannot continue having the same venue for the same matches. Like QB2 cannot be held in Tokyo next year or the following year consecutively. So there are multiple locations you have to consider and multiple constraints in terms of optimizing the scheduling of the matches. So deciding on the stadium is an application, very limited application as it is, but if I may. Now, the question of where to hold the match is a deterministic decision, which to which quantum annealing can be well applied because it's binary. If the Kyushu opponents travels to Kanto, there is some trade-offs in Kyushu team, and the sparse relationship of the trade-off is the key point in this problem. Let me explain. There are 4 teams. The combination 4C2 for these teams, and index K is applied. The number of arrows indicate the K index. And the opponents and dates are already decided. So team TK versus dash T dash K with the time of the scheduled day of SK. Team T on day S held on team T's home, then the deterministic function variable would be 1, and if not, 0. And continuous holding of the games on the same venue can be avoided with this objective function. It looks like a very normal annealing equation, but Y and K indexes is replaced with Z so that the constraint can always be satisfied. So ZK is explored so that other constraints are always met. So it's a ZK problem alone. So substitution gives you the answer. And the sparse trade-off relation I talked about earlier is a 4 regular graph. It's a very sparse graph. Against Chimera and Pegasus models, it can be embedded. So these are the numerical simulation. D-wave advantage is used 0.05 fixed time, and the objective functions realized are on the right-hand side. And the time required for optimization is listed toward the right-hand side. Now, D-wave's advantage has such features which could work very well in this kind of a problem solving. Sports scheduling was an example. But of course, scheduling can be applied to other fields outside of sports. So if you have any interesting use cases similar to this, please let me know. But embedding to Chimera and Pegasus graph still is rather cumbersome, so we have some work to improve there. So once again, lastly, here are some takeaways. D-wave systems have different contents for business applications on the cloud, and there are OSS and other tools available. And there are application case studies and learning blogs, education blogs, and so forth from entity data and other vendors. When you understand the strengths and weaknesses of D-wave, then it will be easier for you to find good applications. So please try it out. There are free trials available. There are certainly difficult parts that you have to do a lot of tweaking, and that's when we can come in and support you in terms of how you can better utilize this type of a technology for your businesses. With this, I would like to conclude. I thank you for your attention.